More than 250 million years ago, long before humans walked the Earth, the oceans were home to predators unlike anything alive today. Beneath the surface of these ancient seas, colossal hunters glided through dim, shifting waters, their shapes sculpted by millions of years of evolution. Some possessed jaws lined with hundreds of razor-sharp teeth. Others relied on speed, ambush, or crushing bite forces capable of shattering bone. For centuries, these creatures existed only as fragments, isolated teeth, scattered vertebrae, or mysterious impressions buried within layers of sedimentary rock. But in recent years, a new wave of fossil discoveries has begun revealing a far more complete picture of these prehistoric ocean giants. Hidden within ancient seabeds, cliff faces, and desert formations that were once submerged beneath primeval oceans, paleontologists have uncovered fossils that tell extraordinary stories. Some specimens are so well preserved that they reveal details of muscle attachment, skin texture, and even the feeding strategies of animals that lived hundreds of millions of years ago. These discoveries are reshaping our understanding of ancient marine ecosystems. They reveal not only terrifying predators but also the complex evolutionary arms race that unfolded beneath prehistoric waves. Among the most remarkable revelations are 7 formidable ocean creatures whose fossils have only recently begun to illuminate their true nature. Each one represents a different chapter in the story of life in Earth's ancient seas. The first of these discoveries takes us back to the early Triassic period, roughly 247 million years ago. At this time, the planet was still recovering from the most devastating mass extinction in Earth's history, the Permian-Triassic extinction event. Nearly 90% of marine species had vanished. Entire ecosystems collapsed, leaving vast stretches of ocean eerily empty. Yet evolution moves quickly when ecological niches open. In shallow coastal waters, a new group of marine reptiles began to emerge. Among them was a creature whose fossilized remains would remain hidden for millions of years inside limestone deposits of southern China. In 2021, paleontologists working in the Guizhou province uncovered an exceptionally preserved skeleton embedded in ancient marine sediments. At first glance, the fossil appeared to belong to an ichthyosaur, a group of dolphin-shaped reptiles that dominated Mesozoic seas. But this specimen was different. Measuring nearly 5 meters in length, the creature possessed an unusually elongated skull and a mouth filled with tightly packed conical teeth. The jaw structure suggested a powerful bite, capable of gripping slippery prey with remarkable efficiency. The animal was identified as a species closely related to Cardarhynchus, but far larger and more specialized than previously known forms. Its anatomy revealed a fascinating evolutionary transition. Early ichthyosaurs had only recently adapted to life in the water. Their ancestors were terrestrial reptiles, and many retained primitive features. But this newly discovered specimen showed a body already streamlined for efficient swimming. Its paddle-like limbs were strengthened for propulsion, and its vertebral column displayed adaptations that allowed powerful lateral movement through the water. The skull told an even more intriguing story. Unlike later ichthyosaurs that specialized in fish and squid, this predator appears to have been a durophagous hunter, an animal adapted to crushing hard-shelled prey. The teeth were blunt yet robust, capable of cracking open ammonites, bivalves, and armored crustaceans. In the fragile aftermath of the Permian extinction, such feeding strategies would have been crucial. Marine ecosystems were rebuilding, and many early prey species evolved protective shells and exoskeletons. Predators capable of breaking through those defenses held a significant evolutionary advantage. This fossil provides a glimpse into that moment of ecological recovery, when new lineages were experimenting with different survival strategies. But the Triassic oceans would soon give rise to far more formidable predators. Roughly 10 million years later, another creature emerged, one whose terrifying anatomy would only be fully understood after a remarkable fossil discovery in Nevada's desert. Today, the barren landscapes of Nevada appear far removed from the ocean. Dry mountain ranges and sun-scorched valleys stretch across the horizon. Yet during the Triassic period, this region lay beneath a warm, shallow sea teeming with marine life. In 2014, Paleontologists excavating rock formations in the Augusta Mountains uncovered a partially exposed skull protruding from layers of limestone. The fossil belonged to an animal known as Thalatorcarchan saurophagus. Its name translates to lizard eater, ruler of the seas. At first glance, the skull alone was astonishing. Nearly 2 meters long, it suggested an animal of enormous size. As excavation continued, researchers uncovered more of the skeleton, revealing a predator that stretched over 8 meters in length. But what truly distinguished Thalatorcarchan was its teeth. Unlike most ichthyosaurs, which possessed small, needle-like teeth for catching fish, this animal's teeth were large, blade-shaped, and deeply serrated. They resembled the cutting teeth of terrestrial apex predators such as Tyrannosaurus rex. This anatomical feature suggested something extraordinary. Thalatorcarchan was not merely a hunter of small prey. It was likely a macropredator, capable of attacking animals nearly its own size. The fossil record rarely preserves direct evidence of such feeding behavior. But the structure of the teeth, combined with the massive jaw muscles indicated by the skull anatomy, strongly suggests that this predator occupied the very top of the marine food chain. Even more remarkable was its timing. Thalatorcarchan lived only 8 million years after the Permian extinction. This means that complex marine ecosystems and apex predators capable of hunting large vertebrates re-evolved far more rapidly than scientists once believed. The oceans were recovering faster than expected, but the fossil discoveries were far from over. Another revelation awaited paleontologists across the world. Hidden within the chalk cliffs of Europe, these towering white cliffs, composed of ancient marine sediments, contain a detailed record of life during the Cretaceous period. Over the centuries, countless fossils have been discovered within these formations. Yet even today, new specimens continue to emerge. In 2018, researchers examining fossils from the United Kingdom identified the remains of an enormous pliosaur, one of the most terrifying marine predators ever to exist. Pliosaurs were relatives of the long-necked plesiosaurs, but their anatomy followed a very different design. Instead of elongated necks, pliosaurs possessed massive skulls, short necks, and extremely powerful jaws. Their bodies were built for speed and ambush. The newly studied fossil revealed a skull measuring nearly 2 meters long. The teeth were enormous, each one shaped like a dagger and capable of piercing thick bone. Computer modeling of the skull suggested a bite force exceeding that of any known marine reptile. Such power would have allowed the predator to crush through the bones of large prey animals, including other marine reptiles. The surrounding fossil deposits provided additional clues. Remains of fish, ammonites, and smaller marine reptiles were found within the same layers, painting a vivid picture of a thriving ocean ecosystem. Within this ancient sea, the pliosaur would have been the undisputed apex predator. But perhaps the most chilling detail comes from microscopic analysis of the teeth. Under magnification, scientists identified distinctive wear patterns, evidence of repeated bone-crushing bites. This predator was not simply killing its prey. It was consuming it entirely. Yet even these formidable hunters were only part of a much larger prehistoric story. Across different geological periods and continents, newly discovered fossils continue to reveal creatures whose anatomy challenges everything scientists once believed about ancient oceans. Some evolved bizarre body shapes never before seen in marine vertebrates. Others developed hunting strategies so specialized that they reshaped entire ecosystems. And as paleontologists continue to explore the rock record, new discoveries are emerging that reveal even more terrifying predators lurking within the depths of prehistoric seas. One such creature would remain hidden for over 90 million years, until a discovery in Morocco began to expose the remains of one of the most unusual marine hunters ever found. The fossils belonged to a creature whose anatomy would challenge the traditional image of ocean predators. Unlike streamlined ichthyosaurs or massive pliosaurs, this animal possessed a long, eel-like body and an array of curved, needle-like teeth designed for trapping slippery prey. Its discovery would open another window into the strange and often terrifying diversity of prehistoric marine life. The Moroccan desert stretches across vast horizons of wind-carved rock and shifting sand. Today, it is one of the driest regions on Earth. But during the late Cretaceous period, nearly 100 million years ago, this land lay beneath a warm, shallow sea connected to the ancient Tethys Ocean. Layers of marine sediment gradually accumulated on the seafloor, preserving the remains of countless organisms that once inhabited those waters. Ammonites, fish, marine reptiles, and microscopic plankton settled into the mud, slowly becoming fossils as geological time transformed soft sediment into solid rock. It was within these deposits that paleontologists made a remarkable discovery. During field surveys in southeastern Morocco, fragments of vertebrae began to emerge from exposed limestone layers. At first, the bones appeared unfamiliar. They were elongated and cylindrical, unlike the vertebrae typically seen in well-known marine reptiles. Further excavation revealed more of the skeleton. What emerged from the rock was the fossilized body of an animal unlike any previously documented predator of the Cretaceous seas. The creature was later identified as Xiphactinus-like elaform mosasaur relatives, a lineage closely related to mosasaurs but possessing a dramatically different body structure. Unlike the massive, robust mosasaurs that dominated late Cretaceous oceans, this newly discovered animal had an extremely elongated body, stretching more than 8 meters in length. Its vertebral column contained an unusually high number of vertebrae, suggesting a flexible spine capable of powerful serpentine movement. The skull was narrow and elongated, filled with slender, backward-curving teeth. These teeth were not designed for crushing prey. Instead, they formed a trap. Fish or squid caught in that jaw would find escape nearly impossible as the curved teeth guided struggling prey deeper into the mouth. The anatomy suggested a hunting strategy rarely seen among large marine reptiles. Rather than relying on raw bite force, this predator likely pursued prey through rapid undulating movements of its body, similar to modern moray eels. Its flexible spine would have allowed sudden bursts of speed, enabling it to dart into dense schools of fish before snapping shut its elongated jaws. The discovery revealed an entirely different evolutionary experiment among marine reptiles. During the late Cretaceous, mosasaurs had become the dominant predators of the seas. Yet even within this successful lineage, evolution continued to produce new body plans, adapting predators to exploit different ecological niches. This eel-like hunter was one such specialization. But even as paleontologists studied the Moroccan fossils, another discovery, far older and far stranger, was beginning to reshape the understanding of early marine ecosystems. To find it, scientists would travel to one of the most fossil-rich regions on Earth, the limestone formations of southern Germany. The Solnhofen limestone is world-famous among paleontologists. Deposited roughly 150 million years ago during the late Jurassic, these fine-grained sediments formed in calm lagoon environments that preserved fossils with astonishing detail. Soft tissues, delicate skeletons, and even impressions of skin have survived within these rock layers. Many iconic fossils have emerged from Solnhofen, including the famous feathered dinosaur Archaeopteryx. But among these discoveries lies the fossil of a predator whose appearance is both bizarre and unsettling. The creature is known as Dacosaurus. At first glance, Dacosaurus resembles a crocodile. Yet it was not a river-dwelling reptile like its modern relatives. Instead, it belonged to a group called marine crocodilomorphs, crocodile-like reptiles that fully adapted to life in the open ocean. The newly analyzed fossils revealed a predator approximately 5 meters long, with a body built for powerful swimming. But its skull was the most terrifying feature. Unlike modern crocodiles with narrow snouts designed for catching fish, Dacosaurus possessed a short, deep skull resembling that of a large theropod dinosaur. Its teeth were enormous and laterally compressed, with serrated edges designed for slicing through flesh. This unusual dental structure suggests a predator capable of attacking large prey animals. Marine reptiles, large fish, and even other predators may have fallen victim to Dacosaurus. Computer simulations of the skull mechanics indicate that its bite was not merely powerful, it was optimized for tearing. Once Dacosaurus clamped onto its prey, violent twisting movements of its body likely ripped chunks of flesh away, a feeding strategy similar to modern crocodilian death rolls. Such behavior would have been devastating in the confined lagoon ecosystems of Jurassic Europe. The discovery of Dacosaurus highlights a remarkable evolutionary convergence. Although separated by millions of years and different evolutionary lineages, the skull structure of this marine crocodile bears striking similarities to large terrestrial carnivorous dinosaurs. Nature had arrived at the same solution for apex predation: massive jaws, serrated teeth, and bone-crushing bite forces. But while Dacosaurus terrorized Jurassic seas, an even more enigmatic predator had already appeared hundreds of millions of years earlier. Its story begins deep in the Paleozoic era. Around 390 million years ago, during the Devonian period, Earth's oceans were experiencing a dramatic transformation. Fish were undergoing an evolutionary explosion. Jawed vertebrates were diversifying rapidly, experimenting with new body shapes and feeding strategies. Among them emerged a creature that would become one of the most formidable predators of the Devonian seas. Its name was Dunkleistus. For decades, Dunkleistus has been known primarily from massive armored headplates discovered in North America and Europe. These fossils hinted at a giant predator, but recent discoveries have begun revealing far more about its true anatomy. Unlike modern sharks or marine reptiles, Dunkleistus belonged to a group of armored fish called placoderms. Instead of teeth, its jaws were lined with sharpened bony plates that formed a self-sharpening cutting edge. Recent fossil analysis has shown that these plates functioned like enormous shearing blades. Biomechanical studies indicate that Dunkleistus possessed one of the fastest jaw-opening mechanisms ever recorded in vertebrates. Within a fraction of a second, the jaws could snap open, generating suction that pulled prey directly into the mouth. Once the prey was captured, the closing force of those armored jaws was immense. Some estimates suggest a bite force exceeding 6,000 newtons, more than enough to slice through armored fish or crush thick bone. The body of Dunkleistus likely reached lengths of nearly 9 meters. Combined with its heavily armored head and lightning-fast bite, this predator ruled the Devonian oceans for millions of years. Yet recent fossil discoveries have revealed something even more fascinating. Some Dunkleistus fossils contain partially digested remains of other Dunkleistus individuals. This suggests that cannibalism may have been a regular behavior among these ancient predators. In the crowded Devonian seas, even members of the same species could become prey. But despite its dominance, Dunkleistus eventually disappeared during the late Devonian extinction event. Like many prehistoric giants, its reign came to an abrupt end as environmental conditions shifted and marine ecosystems collapsed once again. Still, the fossil record continues to reveal clues about the terrifying predators that replaced it. And among the most astonishing of these discoveries lies the fossil of a creature whose sheer size challenges the imagination. A predator so enormous that even the largest marine reptiles may have struggled to rival it. Its remains were discovered embedded within ancient seabed deposits in Peru and Europe. Fragments of vertebrae so large that paleontologists initially struggled to identify them. The bones belonged to an ancient leviathan of the Miocene oceans. A predator whose discovery would reveal yet another chapter in the long and violent history of life beneath Earth's prehistoric seas. The fossil fragments first appeared as enormous, weathered vertebrae embedded within Miocene marine sediments along the desert coast of Peru. At first glance, the bones resembled those of a large whale, yet their proportions were unusual. The vertebrae were thick, heavily built, and far more robust than those of most known marine mammals. For paleontologists examining the site, the discovery raised immediate questions. What kind of animal possessed vertebrae of such immense size and density? And what role did such a creature play in the marine ecosystems of the Miocene oceans? As additional bones were excavated from the surrounding rock, the answer began to emerge. The remains belonged to a colossal predatory whale known as Livyatan melvillei. Named after the biblical sea monster Leviathan and the author Herman Melville, whose novel Moby Dick immortalized the legendary sperm whale, Livyatan represents one of the most formidable marine predators ever to inhabit Earth's oceans. The newly analyzed fossils revealed a skull estimated to measure over 3 meters in length. Unlike modern sperm whales, which primarily feed on squid, Livyatan possessed massive teeth in both its upper and lower jaws. Each tooth could reach over 30 centimeters long, larger than the teeth of almost any other known predator. These teeth were not delicate structures designed for gripping soft-bodied prey. They were thick, deeply rooted, and capable of withstanding enormous mechanical stress. The implication was unmistakable. Livyatan was a hunter of large vertebrate prey. During the Miocene epoch, roughly 12 to 13 million years ago, the oceans were filled with a wide variety of marine mammals. Early baleen whales, smaller toothed whales, seals, and sea cows flourished in productive coastal ecosystems. For an apex predator of Livyatan's size, these animals represented an abundant food source. Computer simulations of Livyatan's jaw mechanics suggest that its bite force may have rivaled or even exceeded that of modern killer whales. But the true advantage of this predator lay not only in the strength of its jaws but in the sheer size of its teeth. Unlike predators that rely on slicing or crushing, Livyatan's teeth were built for grasping and holding large struggling prey. Once captured, the victim would have had little chance of escape. Yet the story of Livyatan reveals something even more intriguing about prehistoric oceans. It did not rule those seas alone. During the same period, another apex predator patrolled the Miocene oceans, one whose fossilized teeth have been discovered in marine sediments across nearly every continent. That predator was Otodus megalodon. For millions of years, these two giants likely shared the same marine ecosystems. While Megalodon dominated as a gigantic shark capable of ambushing whales from below, Livyatan may have occupied a slightly different ecological role, actively pursuing marine mammals in open water. The fossil record cannot yet confirm direct encounters between these two titans, but the possibility remains that some of the most dramatic predator interactions in Earth's history occurred within those Miocene seas. Yet, as astonishing as Livyatan's discovery is, it represents only the latest chapter in a much longer story of prehistoric ocean predators. Long before whales and giant sharks rose to dominance, the ancient seas were ruled by reptiles, armored fish, and evolutionary experiments that shaped the course of marine life. Each newly discovered fossil adds another piece to that immense puzzle. In recent years, paleontologists have begun uncovering evidence of yet another terrifying predator, one that lived during the early Cretaceous period, more than 100 million years ago. The fossils were discovered in marine sediments along the coast of Colombia. At first, researchers identified only scattered vertebrae and fragments of limb bones. But as excavation progressed, a more complete skeleton began to emerge. The animal belonged to a group of marine reptiles known as pliosaurs, relatives of the long-necked plesiosaurs but adapted for a very different style of predation. This particular species was eventually named Saccocsaurus vitae. The anatomy of Saccocsaurus reveals an extraordinary predator. Its body stretched more than 10 meters in length, with 4 powerful flippers used for propulsion through the water. Unlike ichthyosaurs, which relied on tail-driven swimming, pliosaurs used their flippers in coordinated strokes similar to underwater flight. This method of locomotion allowed for both speed and maneuverability. But the skull was the true weapon. The jaws were enormous, lined with thick conical teeth designed to pierce and hold large prey. The structure of the skull suggests a predator capable of delivering devastating bite forces, strong enough to subdue large fish, marine reptiles, or even other pliosaurs. Evidence from fossilized stomach contents and bite marks on other marine reptiles suggests that pliosaurs were not selective hunters. Anything large enough to provide nourishment and small enough to overpower could become prey. The discovery of Saccocsaurus has provided valuable insight into how marine reptile predators diversified during the Cretaceous. Different lineages evolved distinct hunting strategies, body shapes, and feeding mechanisms, allowing multiple apex predators to coexist within the same ocean ecosystems. Yet the deeper paleontologists explore the fossil record, the more they realize that prehistoric oceans were far more complex and far more dangerous than once imagined. At various points in Earth's history, the seas have been dominated by armored fish capable of crushing bone, serpentine hunters that moved like underwater lightning, crocodile-like reptiles with dinosaurian jaws, and whales whose teeth rivaled the weapons of the largest sharks. Each discovery reveals a moment in time when evolution produced a predator perfectly adapted to its environment. But fossils also tell another story. They remind us that no predator rules forever. Environmental shifts, climate change, and mass extinctions repeatedly reshaped marine ecosystems, removing dominant species and opening new evolutionary pathways for those that followed. The Devonian seas that once belonged to Dunkleosteus vanished long ago. The Jurassic lagoons of Dacosaurus gave way to new ocean basins. The mighty pliosaurs of the Cretaceous disappeared alongside the dinosaurs. Even the titanic Leviathan and Megalodon eventually faded from the oceans. Yet their fossils remain, preserved within ancient rock layers scattered across the world. For paleontologists, each fossil discovery is more than just a skeleton. It is a window into a vanished world. A world where prehistoric oceans were filled with colossal predators, locked in a constant struggle for survival beneath dark and ancient waves. And as new fossil sites continue to be explored, from desert cliffs to mountain ranges that once lay beneath prehistoric seas, the possibility remains that even more terrifying creatures are waiting to be discovered, hidden in stone, silent for millions of years, but ready to reveal the next chapter in the extraordinary history of Earth's ancient oceans.